Hey everyone, and welcome back to the stream. This is Josh Justice, aka Coding It Wrong, as usual, and I'm glad you're here. If you're here on the chat, if you're watching on the stream, say hello in the chat. I'll just say hello to folks, and I love feedback, questions, comments on what we're doing as we're going through these testing exercises together. This week we are picking up once again with what we started last week, test driving a complex function. So this gets us away from framework and UI specific things into just the TDD process of getting a complex function to work. And if you weren't here last time, I didn't pull up the page. Let me pull up the page that this is on so we can see it. Coding it wrong. It's called natural language. It's not really a natural language processor, so if you're into machine learning, you can correct me. But what I want to be able to do in this project that we're doing is to take some words like very large red dog and turn it into a data structure. So I can tell what type of object it is and then what attributes are being set. Like the color is that and the size is that. And this is the kind of thing that we could use to take something like natural language and be able to use it in the future to make some kind of 3D world out of it where you just write what you want to see and it gets created for you. So that's kind of the theoretical idea that I'm moving towards. It is something I've been interested in playing with for a while. But in addition to that, it's just a great way to kind of try out the test-driven development process. So we've been building this app. It's just a simple JavaScript module with a set of different functions that we've split things out into. And we have some Mocha tests that we wrote to test drive this out one piece at a time. And one of the interesting things about this code is I don't know exactly how we're going to implement it. It's big enough and non-trivial enough that we're figuring that out as we go. And I'm taking the test-driven development approach of just writing one test at a time and then writing the minimum code necessary to get it to pass. That prevents me from over-engineering it from the start. And it allows me, for me, it's very helpful to be able to think of just one aspect at a time. And in this case, I'm not even sure all the different features we're going to be having in this function. We're just going to figure it out as we go. I've noticed now, just as I've been getting this project up and running today after not working on it for a week, that this list of tests here is actually pretty helpful to help me understand what it is that we've coded so far. So what does the parse function do? And actually, even just seeing this, I think I might add parentheses there to make it clear that it's a function. So the parse function, what does it do? It parses a single word that's a type of object, or a different object type, a single attribute, or a different attribute. It can parse two different attributes at the same time, and a different value for an attribute, so values can have different attributes can have different values. It skips unrecognized attribute values, and then it can parse two different objects. So that's as far as we've taken it so far. Let's take a look at my list and see where we want to take it from here. So one thing we want to do is we want to make sure that we want to make sure we don't have contradicting attribute values. So for example, let's say we have big and small as two different sizes. The possible attributes and values are configuration that we pass into the parse function. But so let's say we have big and small size. So let's create a test that confirms we can't say something is big and small. So let's see here. How do we want this to work? Throws an error upon contradicting attribute. Conflicting. So we want to throw an error upon conflicting attribute values. So if we say a big, small dog, what do we want to do? What are we expecting? Well, in this case, I've decided here that since we're just kind of returning a data structure, maybe we'll throw an error as a result of what happens here. My phone is ringing. Let me stop this. I think I'm going to throw an error instead. And so I forget how to do this, how to check this with Chai, which is the assertion library we're using. All the patterns we're looking at here would work just fine with Jest as well, or most other test runners. But we're using Mocha, Chai, and Sign-On because that's what I'm most familiar with. So let's take a look here in the docs. We'll go to chai.js.com, where the assertions are done, API documentation. We want to assert that something throws. So, not assert, we want to expect, because the expect approach is what we're using. Okay, expect the function to throw. So when the function is called, we expect, and it will show throw the type. When one argument is provided and it's a string, it asserts that the error is thrown with a message that contains that string. Expect function to throw salmon. That's hilarious. All right, cool. All right, so this is what we want. So expect configure parse input to throw let's say conflicting attribute values. Maybe we'll think of some better message for now. So This actually won't work though, and the reason why is before expect even gets a chance to run, this function would be called. So if you look at the docs here, we have a 0 argument function that's passed into there, and then expect or the throw, something in the mechanism of Mocha and Chai will run it there. So we're deferring the execution until such a time as the test handler can make sure it doesn't fail. So in this case, we want to pass an arrow function there, so that's gonna wait until then. That's a little bit wide for a line. But it's not too bad. In fact, I'm going to put this on a separate line. I think that'd be nice. And it wants a comma there. Conflicting attribute values. So let's run this and see. Okay, the tests run extremely fast, and they say expected function to throw an error. And so I believe the point there is that it does not throw an error. I wonder if there's a way to see the output it has. But regardless, even if we can't... Yeah, well, I mean, we could just do a... I'm sure there might be another way, but console.log... log it out, and then we could even... Oh yeah, there we go. Type dog size small. So what happened here so far is just that the last value for that attribute wins. We end up with a small dog. But to kind of give better feedback to the user, like I'd rather error out and say, hey, like what you're saying there doesn't make any sense. So let's see how we could do this. Go into the code. We've broken things out into a number of different functions, but in our top parse function, we then parse separate sentences, and then we parse the type and the attributes for the type. So in parse attributes is where this is going to happen. As a quick reminder, notice that we're not exporting and we're not testing all these individual functions. Instead, we're just testing the outer interface of the parse function itself. And that's especially useful now as we're going through this, and any amount of refactoring might happen in the future. I have zero confidence that the approach we're taking right now is what we're ultimately going to take. And so by only testing the outer function, that's going to maximally allow us flexibility for refactoring in the future. And even once we get things nailed down, unless I find a need to really drill into some of these individual functions to test them, I'd rather stay like this so that the module is encapsulated and it's only the external interface of the module that we're testing. But we are looking in parse attributes right now. And so I think what we're saying here is every time we find an attribute, we just set that value into the attributes object here for it. So I think right here what we want to do here is instead test what's happening. So we say we're looking at each attribute value, and then we're looping through the attribute names to see if it matches. So if we find the name, the attribute name, and then the value, then we set them on there. So I think we want to check here. So we say if there's already an attribute name, then we want to throw new error. Is that how that works in JavaScript? I don't really manually throw errors too often in my JavaScript code. It's not too common, but in this case I think it makes sense. And what did we say? We said, well, let me just actually do this. A lot of times, if you want to take very small steps in test-driven development, you actually fix only the amount of code to get past the current test failure or error. And so in this case, just throwing some kind of error will get us past here, and then maybe the test will tell us what the error message needs to be. So yeah, here we go. So I saved. It said expected function to throw an error including conflicting attribute values, but got empty string. So we can just add that in. Conflicting attribute values, and that passes. But now that I'm looking at this in the context, I think what I want to do is be able to say which attribute it is. At least that. I mean, like in the future, maybe you add all kinds of helpful error output that said, like, here's the values that were passed. We could say conflicting values for attribute. Actually, let's test drive it first. Instead, I think what I want to do, conflicting values for attribute size. Conflicting values for attribute size. So now it's not passing again because we've changed the text. Conflicting values for attribute name. Oh, and then we put that in quotes. And I like that. This seems really great. Okay, cool. So we've got now an error message if we have conflicting attribute values, but see that our other tests are passing. And so when we've got different different attributes, different values for different attributes, it's accepted just fine. So that's great. All right, well, let's see what's the next function we want to do. So now that we have error messages reporting, I think I might actually not want to do this anymore. Yeah, like I left myself a to-do and everything. Previously, I said it skips unrecognized attribute values. And that was because at the time, I was like, I don't know, I don't really want to think about error handling at this point. And it seemed like just skipping an unrecognized value was acceptable at that point. But now we got down to a case where I really felt like we needed to throw an error. Now that that pattern's in place, we could go back up here and change this. how do we phrase this? Throws an error upon unrecognized attribute values. So instead, with quizzical red dog, instead we want to say configured parse, expect it to throw unrecognized attribute quizzical. And now we save, and this happens here. Expected function to throw an error. One quick note about my decision process here. When we are looking at this the throw function here in chai, it says you can check just the fact that it throws something, or check that it throws an error of a certain class, or just check that it throws an error with a certain string in the message. And your needs might be different in some place that you do the code, but I think checking for the error messages is best. If you just check that it throws something, you can run into a situation where some different kind of problem, like you just get a whatever the JavaScript equivalent of null pointer exception is, where you just have a typo, that'll be accepted. Like, hey, you threw an error, you have a typo, that's fine. So that's not helpful. Like, you want to know that it's the right kind of error. And you could check the type, like the actual class of the error, but oftentimes, maybe if you've got a larger library and you have some very clearly defined errors that you want people to be able to type check on, that's something that you could do, but that's not as common in JavaScript. I think having a descriptive message is more helpful, and at least at the early stage of the project we're on, this doesn't couple us to any specific error types, because I don't really feel like creating a specific error class anyways. I just want some kind of error message to be sent up. So that works best for me, and I'd probably use that in production applications as well. Okay, so we need to change our app to throw an error upon an unrecognized attribute values. So let's do that. So here we go. We say, okay, attribute names for each. So as we're going through here, like if we find a match, the value is found for a certain attribute, then we do something. And then if none are found, though, we don't do anything. There's probably a better way to do this with kind of functional programming approaches, but we're going to fall back in the old stateful way of doing it. And again, one of the nice things about TDD is you can write the simplest solution first, and then you can refactor it later once you can see the code in front of you. So what we want to say is, okay, for each attribute name, we're going through, so each of the values, these are the values that were passed in by the user. And then we can say const attribute found, let. So the attribute found is false. And then if the possible values includes the value, that's when we want to say attribute found equals true. And then at the end here, as we list through all the attributes, we could say, let's actually line break this down here. If attribute found, if the attribute is not found after looping through all of them, we could throw a new error. And what was the text? Oh, well, once again, I've forgotten what the message is, but that's fine. Our test runner will give that to us. I've done something wrong. Oh, there we go. All right, something else's error is out, but that's fine. We'll come back to that. It throws an error upon unrecognized. So we expect the error to include unrecognized attribute quizzical. So we'll just say that. Unrecognized attribute, quote, attribute name. So now we're erroring out when attribute name is found. Oh, no. Value. It's the value. The value we have that was not found. And now that passes, but now we've got another error that's happening. Parses two objects. Unrecognized attribute empty string. And I wondered actually about how this was going to happen tokenization-wise. So let's go dig in and see what's happening here. This is the case when we're parsing two objects. Red fire, green leaf. And so this is being split up. We take this sentence of a string that has two sentences. We split it upon the dot. And then we go from there. So the second sentence is going to start with a space. And I think what's going to happen is when we split it, based on the space there, we're going to get an empty string at the start because there's an empty string, there's a space at the start, and so there's an empty string to the left of that space. And in the past, that empty string was just ignored, so that was fine. But we need to handle it a bit more explicitly now. What would be the right place to do that? We split it into tokens. I think basically at this point, just ignoring empty strings would be great. And I feel like there's, in a lot of string processing libraries, there's a way to do that. So let's find out if it's there in the ever so thorough JavaScript standard library. What is this going to be? This would be on array. In Ruby, it's called compact. probably need to do a filter out the empty strings. Yeah. Or we could trim before we split it. Right now, let's do a trim. And we can refactor that in the future. All right, we trim it, and then it splits it, so that's fine. Okay, cool. Sorry, we trim it, and then that gets that test passing. So this is fine. We're now throwing an error upon unrecognized or conflicting attribute values. So that's great. We got a little bit of error handling. So let's see. Let's get into something more complex. So we don't want to have... We have the ability to have two different attributes. We have the ability to error out if we've got conflicting attributes. But another thing we'd like to be able to do, as I mentioned in the the README for this, was that I'd like to be able to have intensifiers. So something like very large red dog. And of course, what this looks like as far as turning this into like something concrete to render out in a 3D rendering app is kind of subjective, but that's okay. That's kind of a future implementation problem we can think about. Right now, we want to be able to handle it. So let's create a new test. We're going to do the green step of our red-green refactor cycle here. So it's adverb is the parts of speech. Yeah, adverbs that modify adjectives. I think adverbs are used for several different things. Very large dog. So when we pass a very large dog, so now we need to think about how to make this work. We are going to have type dog and then size. So in the README, I said size very large. That's not the most useful thing in the world though, because like I'd like to be able to have that to be two different fields where the attribute value is large and then the adverb or the intensifier or the qualifier is very. So I wasn't totally sure what to do because I do want to be able to have just a simple string for the attribute when it's just a simple plain one, but I want something more structured here. And I think thinking about it now, JavaScript is definitely a language where kind of using types flexibly and having the data structure represented in these simple object literals, we want it to be flexible. So I think thinking about it now, doing an object literal here would be good. So the size, the value is large, and then the qualifier is very. So we're saying, so what is the size? It's large, it's very large. So that seems like a nicely structured way to do it. So let's run this. Okay, so now what's happening here is the code, the parse function is not yet set up to be able to think about adverbs as intensifiers or modifiers. So it's thinking that that's a separate attribute, and there's no attribute called vary. So I think what we want to do, my initial thought for how to handle this until we get into some kind of crazy machine learning thing in the future, would be I would like to have a specific list of adverbs. So just in the same way that we have attributes, keys, and values, I want to have like a configuration, possible adverbs. Is adverbs the right word? Because before I didn't use the part of speech. I didn't say adjective. I said attributes. So let's say intensifier. In fact, let's just say intensifiers because I think that's going to make it simpler as far as the data that's passed in. Now, do we want to qualify this now to say that something can be very big? Can it be very red? That is something that's used in day-to-day language. It may be that we decide in the future that that's not okay, but I want to stick with what's simplest for now. Again, this is the kind of thing where you could just think yourself into a corner, thinking about all the possibilities for what you'd like this to handle. Instead, by building things out, test driving one feature or one test case at a time, we've got functioning code as we go. And so we're not in a situation for days and weeks or weeks and weeks of live streams that nothing's working. We've got things working, and then we're just gradually iterating on it to make it better and better. This puts the code in a state where you could show it to stakeholders or end users and deploy it and get feedback on it earlier. So that's a really nice thing and something really valuable about agile approaches. So for now, let's keep it simple. Let's just have a flat list of intensifiers. Maybe for a future test case, we can think about if we could find ones that don't make sense. So let's say vary. I feel like that's something English teachers and writing coaches say. Don't just say vary. Say vary and slightly, just to kind of give an example of how those might be used. So let's pass this in. We have our plain parse function that's imported here, and then we have configurations that are passed in. And I've set up configured parse at the top of our test because, at least for right now, I'm not varying that from test case to test case. For most of my test cases, I just want to be able to have a configured parse with these hard-coded values to test against. So let's break this into multiple lines to make it clear. Intensifiers. So now we're passing in the intensifiers, but it's still not being recognized. So I think the next thing I want to do is, well, certainly the next thing I want to do is to take this data and pass it along. So we've got our config passed into the parse function, parse down to parse sentence, parse down to parse attributes. And now that this signature line is getting a little long, I think I'm going to take possible attributes out of here. Say config, and here I'm going to say const possible attributes intensifiers equals config. So we'll pull up possible attributes and intensifiers fields out of the config, and then we'll use them. Let's just save and make sure we're still getting the same error, and it's not clear that we are. Unfortunately, this error is a little long, so on the font size here, I have to scroll to see it. But we are still getting the same error. So what do we want to do? So I think what I want to do currently is, as we're going through the attribute values, and I might need to change the name there because it's not necessarily an attribute at this point. And even the name of this function, it's not really attributes. It's just the other modifiers. But let's let that play out, and we'll rename it at the end. So we have attribute values. Let's rename this at least to tokens. We've passed in tokens. This is interesting. Okay, so let's say, well, let's leave these names for now. We can improve the names during the refactoring stage. So we get a value. Let's just think about value. We don't need to notice if an attribute value or an adverb, an intensifier value. So let's check for that first. Instead of checking through the attribute names, let's say if intensifiers includes, I always get that backwards. If intensifiers includes value, then we'll just hang on to it. And again, we're going to continue to take the stateful approach right here. And let's just store it in a single variable for now. Maybe we'll find later that we need multiple intensifiers. That could be worth thinking about for our next test case. I'm going to make it to do. Think about if we need to store multiple intensifiers. So we'll leave that to do for ourselves. So we'll say lastintensifier equals value. And then we'll say we want to skip the rest otherwise, so we'll say else. Actually, we can just return. That'll be simpler than doing that. And this return, because we are in an arrow function passed to for each, this return will just take us out of this loop and go to the next attribute value or the next word or token. So lastintensifier needs to actually be stored on something, and that's outside of the list of attribute values here because we want to save it for the next one. We say let lastintensifier equals null. So we default it to null, and then we set it there. So let's say we're looping through, we find the word vary, we store it in lastintensifier, and then we go on to the next attribute value, which will be large. So we find large in here, and then we are assigning the attribute onto here. So here's what we need to think about what to do. So here we found it, we found the value, and now we say if lastintensifier. So if there was an intensifier, we're going to assign to that attributes an object, and it's going to have a value, and it's going to have, what's the structure? Qualifier. I think I'm using my terms incorrectly here, inconsistently. So we'll get the terminology right in the refactor after this. So the qualifier will be the lastintensifier. And if there's not a lastintensifier, we're just going to assign the value itself. And then also after this, once that lastintensifier is assigned, then we need to clear it out. I might want to set another test case to cover that, though. Okay, so I'm going to save that. So I save this, and then what happens? Unrecognized attribute large. That's interesting. Large? Oh, big. Sorry, it's not large is not in the list. Big is in the list. You save. Recognize attribute large. Oh, right. And then large needs to be up there as well. And now it passes. So this is great. So now when we have an adverb like very, we get an object for that attribute there. And then when we don't have that, we just get all the other tests passing, where they're passing just having the attribute is set as a single string. So that's really nice. So let's go back to the to-dos we set now and handle them one at a time. So we think that if we keep the lastintensifier indefinitely, that could cause a problem, because then it's going to be applied to all the future words. So let's see if we can come up with a test case that's going to demonstrate that problem. This is why in a TDD approach like this, these are often called examples rather than tests, because we're giving the examples of the kind of functionality we want, and then we're showing illustrations of what should happen. And then we can say here, it applies adverbs only to the next adjective. So if we say very big red dog, the idea here is this. Very applies to the word big only. It's not very big, very red. So what we want here is we want to have size is that and color is red. And I think this will not happen. I think this will error out because I think it'll say very big, very red. So we save and then check it out. Yeah. So we expect these values did not match, and we're getting a nice diff from Mocha's output here to see. We got the right size of very big, but expected we had color red, and actually we got very red. So we got very big, very red, and that's not what we want. So I think the way to handle that is to clear out the lastintensifier, is to say lastintensifier equals null, and then I think we'll be good. And we are. This is great. So now it confirms that an adverb only applies to the very next word, and then if we wanted to say very big, very red, then that would work. Actually, let's see. Very big, very red, then that we were able to get that in. So that kind of fits at least the kind of version of English that I'm thinking about here. That fits a bit more closely. Okay, so what else? Oh, we had another to-do. Let's go back and look at that. Think about if we need to store multiple intensifiers. So would there ever be two adverbs in front of an adjective? Well, let's think through that and see. I mean, I'm sure linguistically you could come up with that, but let's see if that's realistic. What could we do? And we could stick with the Clifford the Big Red Dog and think about size is kind of one-dimensional. So you could say very, very big. I don't know if I want that to apply or make sense. Maybe that's an edge case we want to handle, but that's not the main kind of edge cases that I want to think about here. So what about with colors? Colors can be modified in several ways. Like maybe it's bright red, light dim. I mean, because you have hue, saturation, and value. I don't know if I want to get into words like sparkly right now. I mean, Clifford could be a sparkly red dog, so that could be cool. But it's maybe he is not dim. I'm having trouble thinking of the adverbs, or the adjectives. Dull, so like dull red. Dull versus rich. Yeah, you could have light, dull red, which I guess would be pink. Or you could have bright, dark. Yeah, that's not. This is not feeling too natural. This is feeling a little forced. Let's see what else. I mean, maybe the point is that having multiple modifiers is not seeming too natural at this point. So let's not worry about it. We don't need to force this. I want to let this develop naturally as we think of different kind of modifiers. So let's see here. Do I want to keep that? I'll keep that to do for now, just in case we decide to get there later. This method is getting kind of long. Before we do anything, though, I want to think about the names. So let's think about the names that came to mind as I was typing up these different things. It's nice because we're thinking about our app from the outside. We thought about the name of the test. I used the word adverb here. But then in the actual interface, the return value, I thought about, what is the value of the attribute, and then what is the qualifier? So adverb is like the linguistic word, and I don't want to work around that unless we decide to take this in a very linguistic direction. I want to think more about the concepts we're modeling. So there's attributes with values, and they have qualifiers that qualify that value. So qualifier seems like a good word. So let's kind of go through and rename things. We'll say instead of intensifiers, let's call this qualifiers. We'll save this, and this should make things blow up. Yep. And so then let's go in here and say qualifiers. Last qualifier. Module qualifiers. Okay, we're just renaming qualifier, intensifier to qualifiers through here. Yeah, okay, so now this is consistent. The property name of the object we're returning and the local variable we're using on it are consistent. So that's great. Oh, the other thing is, come in here. When I first named this, I named this possible attributes because that made sense at the time. But now obviously the configuration for the parser, obviously it's configuring the kind of possible attributes that are available. And I didn't want to have to say possible qualifiers and possible anything else. So I think I want to rename this just to say attributes. Let's say attributes here. That's going to make things blow up. And then here, attributes. We may find that we need a different name internally, but that seems like that's good from the external standpoint. And this is a very long error message. Duplicate declaration attributes. I wondered if that might happen, that general word attributes doesn't make sense inside the function itself. So that's okay. Oops, I closed it. That's not okay. So we'll open up parse.js. So I think what we can do here is at the point we're assigning it here, we'll just say possible attributes. Maybe you want to change this. Maybe this is parsed attributes. I think that makes sense. That makes it clear what that's for. Return parsed attributes, and we assign onto the parsed attributes there. And we'll see if we got those changes right. And we got all those changes right. So one of the nice things about having good test coverage is that you can be more encouraged. You can be more encouraged to do refactorings like that to improve the names of things. The next thing I think I want to refactor is this parse attributes method is really long, and it doesn't even correctly, well, it sort of applies. Now that we've worked through this, we found that it actually sort of does apply because we're parsing attributes and the qualifiers that go with them. So it is an array of attributes that's returned back and is assigned to the attributes there. So the qualifiers is not separate. So I think the name parse attributes is still fine. It's just getting kind of long. So let's see at what point we could split it up. At some point in here, we could find something, a subsection, a subfunction that we could find that will help us. That we could give a name to give it clarity and separate it out so we don't need to think about it at the time. So one very small thing we could do is we could section up this logic that just says the attribute value based on the value and the qualifier that gives us an object or just the string itself. So that's nice and small, and I think that would be easy to pull out. So let's make that something. We're going to extract this method. And let's actually take some small steps here to do this extraction, to extract this function, I should say. This is kind of following the steps like in Martin Fowler's, not following the actual steps, but taking the approach of taking small steps to keep the test passing as we go. So what we can do is, let's see here. I'm going to do parse attributes, attribute name, and I'm going to assign the result of a function here. Format attribute. And so this is going to error out because that format attribute is not defined. So we'll just define that. And now everything passes again. And the reason it passes again is because I've added this up above here where we're going to overwrite that value anyways. And what this lets us do is keep our test passing while we're waiting, while I'm getting this working. So I think what I want to do, I'm going to move this branch down into this function. And we could just move this whole block if we wanted to. But for right now, I'm just going to move this branch. And I'm going to have it return, take in the value, and return the value. In fact, I'm going to make this a named string, an object here, an options object, so I can have named parameters because I think that's going to help. Format attribute value. It still passes because we're still overwriting it. But I think what I can do now is in the else case, this function now handles the else case here. So I think I can just remove this else case. And it's still passing. So this is allowing me to take small steps as we go. Alchemist, thank you for giving me a very surprised face. Tell me what you mean. Are you surprised by this small step approach? Are you surprised that it passes? This is the first time I've gotten a reaction emoji, so thank you so much for that. I feel like I'm growing as a streamer. This is great. Okay, so next we can take this other branch and add it into there. So we can say, we're going to put the actual condition in, and I'm going to actually make this a block. Actually, I'm going to do this as several steps here. I'm going to turn it into a block, and it returns, and it's fine. And so now I'm going to put an if in there. I'm surprised you can finally watch me on Twitch. That's great. I'm glad you're here. Oh boy, so much surprise. This is awesome. Alchemist, thank you for being here. Okay, so now we have if last qualifier. So we're going to pass in let's call it last qualifier there. And now we're not setting this value, we're returning this value. Oh, and then, but overwriting last qualifier here is going to be interesting. I think we'll still handle that out in the other method. So if there's a last qualifier, we return that. The tests still pass. And so then I think if there's a last qualifier, we can just remove this because we still need to overwrite that last qualifier value, but we don't need to set the attribute anymore. Oh, it didn't work. Oh, because we're not passing it in. Here, let me undo that change. Add any last qualifier. And now let's try to remove this part again. And now things are passing. So yeah, and I'm going to put this on multiple lines because at least on my screen here, it's going to be more visible that way. So now we've separated out formatting the attribute happens here, and then checking the qualifier to clear it out happens here. So those are separate, so that's kind of nice. Another minor refactor I'd like to do is I don't want to call it last qualifier because from the standpoint of format attribute, it just knows that this is a qualifier that's appropriate, that's passed in here. So let's change this to just say qualifier. And then here we're going to say qualifier is the last qualifier. And that's now passing. So now format attribute says if there is a qualifier, we return an object, and if there's not a qualifier, we return the string. And I think although this passes, I think I want to have an else statement here because that's going to show these are two equally likely possibilities. You might have a qualifier, you might not. So those are now passing, and that's now kind of showing that bit of logic. So let's see. This function is still pretty long. So let's kind of see what else we can pull out. I think maybe removing this extra token could be something that we might do. Let's think about that. Attributes found. If we found a qualifier, we could find that and assign it, and then attribute names. So we're looking through possible values. So we could find, might actually be something that we could pull out not all of this, but the searching functionality to find the attribute names and pull that out. So let's think about this. Like let's say we had attribute name equals find attribute name for value. So yeah, we take the value we have and say we had a function that would just tell us which attribute name, if any, matched. So let's try to do that. Let's try to extract that function. If we say, first of all, it's going to say that function does not exist. So let's create it. Now that's passing because we're not doing anything with that variable. And my linter does not require me not to have unused variables. So let's now pull this out. We'll pull out the attribute names. And in fact, let's do named parameters here. Named parameters, or like an options object, is extra nice when you're not sure of the interface that your functions are going to take, and so you can change them up very easily. So we'll pass in the attribute names. I might even go and turn this into an object at some point, because that's the way I roll. My old school object-oriented style. So we're going to take in attribute names, value. Alchemist is a fan of named parameters. Sweet. Oh, we need the list of attributes as well. In fact, I think attribute names is only used here. So I'm going to move the assignment of attribute names down. We could maybe performance optimize this, but for now this is going to keep the design of our code simpler. We're just going to pass in attributes up here. Attribute sames, no, just attributes. And then in find attribute name for value, that's where we assign the attribute names. Oh, looks like we need the attribute found variable as well. I guess I maybe shouldn't have cut that out. Let's undo the cutting. Let me take this back. What am I even undoing? Okay, I'm going to leave that functionality there, then I'm going to paste it down here. If you're fancier than me, you could probably do this in fewer steps. Attributes and value. Let's pull that. Okay, so we're going to need attribute names out here still, but let's copy it down, and then it'll get deleted out of here later. Attribute names. Attribute found is going to come down here. Looks like we didn't need it all the way up at that point either. Attribute found is there. Parsed attributes. Okay, so this parsed attributes, this is where we start assigning it to stuff and doing other kinds of things. So I think this is the point where I just want to return. I guess the fact that we're using the for each actually causes little problems there. So actually, yeah, I think I know what we can do. We can maybe do that refactor a little bit later. But we could say, let's just call this found attribute equals null found attribute. We found attribute name. We can call it that. An attribute name. So we set found attribute name to null. Then we look through all of them, and if it matches, we set it on there, and then we return that found attribute name. So that is now going to, well, let's just save. It did blow up. Okay, so something is erroring out here. So let's just make sure it's in that function. It is. So find attribute names. Oh, attributes is what we want to pass into there. Okay, cool. Find attribute name for value. So let's just call it attribute name. So now that this is here, I think we can short circuit some of this. I think we can say if attribute name, so attribute is found. So if there's an attribute name, we say attribute found is true. Again, I want to minimize the changes that I make elsewhere in the code, so let's get this passing and then we'll do that refactoring, because I'm already making a bunch of changes at once here. If the attribute is found, if there's an attribute name, set attribute found to true. And then we could say, I think we do all this. I think all of this happens in here. Then if there is already a parsed attribute for that name, we throw this error. Otherwise, we set it on there with a format attribute, and if there was a qualifier, we clear it out. I think that's going to start to error out because this functionality is happening. So let's remove this. And now we save, everything is still passing. So we've successfully refactored our code to put find attribute name for value down here. And notice this isn't the way the code was set up before. Previously, this finding was intermixed with the doing something with the found name. And so that's, we could have done that refactoring in a different step. And if I was more prepared in the future, maybe I can do that. But we worked through it as far as kind of splitting these things out. But now we have more refactoring that we can do. So let's think through this. I think attribute names is not actually used in this function, so we can delete it. And it still passes. All right, attribute found, I think we don't need that anymore because we actually have the attribute name value instead. And so we can just delete that, and we say if there's no attribute name, we throw that error, and that's still passing. And then now, in fact, instead of just checking for that, I think what we can do, we can just return here, and then we don't even need that, because then just if we fall through, this checks for a qualifier, this checks for an attribute, and then this throws the error. So that's now simpler. Let's click down here and find attribute name for value and see if we can make this simpler. Probably using some sort of functional approach on the array would work here. So I think what we want to do is use find. So we're going to do find, and then just return the value. So so we're looking through attribute names, and when you're using the find method, I believe the function you passed to it needs to return true or false, indicating if it was a match. So now we can say if possible values includes value, we return true. And that passes, so that's great. And so now we can actually simplify this and just say return possible values includes value. That passes. And so now we can actually inline this as well. So attribute name includes value. That works. We can maybe even inline attribute names. This might make it more confusing, so let's see. So yeah, I don't like that as much. Let's put it back. I want to name the attribute names, and that's there. Again, that's a performance thing we might optimize in the future. So we're finding the attribute name for the value. So this will return the name of the attribute if it's found and null if it's not found. So this is great. This function's still long though. Like I feel like there's something else we should be able to do. We are saying, so for each of these attribute values, we're going through here, we're saying if we find a qualifier, go with that. Otherwise, if we find an attribute name for the value, go with that. Otherwise, we throw an error. So this block, this if here is a little long, so I wonder if we could separate this out. We are using kind of state that lives inside this function, so maybe we can't. If last qualifier, yeah, so we're checking for conflicting values. That's something we could go for that. So even this check, we could separate out into another. It could literally be called check for conflicting values. I don't know. I think I like having the error throws inlined here as well. The other thing that feels very stateful is like looking for these last qualifiers. And I suppose if you had like more complicated parsing, you could kind of go through and handle that in a more immutable way. But this seems the most straightforward to me, so I think it's great. Return parsed attributes. Parsed attributes, attribute name. All right. All right, well, there's not obvious refactors that I can make to this function right now, so I think we're probably good. So let's look at where we are. We have adverbs and intensifiers. Contradicting attribute values. Now, I think the last thing we could think about here that might fit within the time we have, and this could be a refactor, is does it make sense to, if we have adverbs that don't match? I think it might. So let's think of an example here. If we can't think of a good example, we won't do it. But let's see if we can think of a good example. Very red could make sense. But what if we said, so like light red, so light big. I'm trying to think of words that don't sound like adjectives. You said like bright red sounds like a color thing, but then like faded red sounds like a color thing, but then faded large doesn't sound like a contradiction. I want to come up with one that sounds obviously like, you know, just as a normal English speaker reading it, you could tell that there's a problem. So let's very large. Man, yeah, color and size. This is not helping. Very loud. So there's bright and dim. Sparkly shit. Dark large dog. Yeah, the word dark doesn't really make sense out of context. So let's say, so dark red dog makes sense, but a dark big dog does not make sense. So let's say throws an error on adverbs that don't match. Yeah, I hate it when the single quotes get in my way. Throws an error on adverbs that don't match the adjective. So we want dark big dog to throw. And we'll just say something like dark cannot be applied to big. Maybe we come up with a different error message later. But we'll just say dark cannot be applied to big. We run, and then it says, okay, so we expected to get the error dark cannot be applied to big, but we got the error unrecognized attribute dark. And so this is one reason that it's really important, oftentimes, not to just say expected it to throw, because then this test would have passed and we would have thought we were fine. It was just because we were missing a config value. So let's add this in first. We're going to need to change this data structure, but let's just to get past this error, let's add light and dark. And now we expected it to throw an error, but it did not. It actually passed. And so let's actually see. Let's console log, and I do definitely use console logs a big amount as I'm going through my testing, just to see the output when the error output does not give it to me. So yeah, so this said, okay, you've got a dog. For the size attribute, the value is big and the qualifier is dark, because our code currently doesn't care about which qualifiers are applied to which attributes. So let's change this now. To get this passing, we are going to need to change our data structure. And so let's see how we can do that. I think what I want to do, before we do anything else, I want to pass this, skip this test, because I want to make changes. I want to make these refactoring changes under green to make sure other tests don't fail. So let's say skip throws an error on adverbs that don't match the adjective. That's now being skipped, so we're seeing that the rest of our tests are passing. So let's now refactor this data structure. We're going to say for the colors, instead of passing in an array, we're going to want to pass in an object to pass a few different things. We're going to say the values for color are these, and because we're going to want to be able to say qualifiers is light, dark. So but before we do that, let's just make this one minor change. Values big and small. So we've just taken these arrays that we were passing to these attributes. We've now wrapped them in an object that's going to give us more flexibility to add qualifiers in the future. And I love this about the TDD approach. You guys hear me talk about that a lot. But I love not having to think about that data structure from the start and over-design this complex system, but being able to make changes as we go. So let me save the changes here. Things are going to blow up. And just looking at one of the error outputs, it says attributes attribute name includes is not a function. So attributes color is no longer an array, it's now an object. So now in our code so far, just to get this passing, all we need to do is find uses of attributes attribute name and then add the dot values in. So let's do that. In fact, it says that the error is on parse.js line 81. Wow, we've written a lot of code in here so far. Yeah, that line number does not look right at all. So let's see if we can find out. I think it's here, find attribute name for value. Values includes. And that now actually passes. So this was the only line we needed to change to handle this adjusted data structure. So that's really sweet. Now we should be able to add qualifiers in here, and if I've got the syntax right, it shouldn't blow anything up. Now we're good. So now what we can do, now that this refactor is done, we've got these qualifiers here, I can unskip this test to go back to it, get it erroring out again, and now I've got a case that I could check for. So what we want to do here is when we go in here, we see we're formatting the attribute. Now, right now, I'm going to put the error throwing in this function because I'm not sure. Like, this is cluttering out this function, so maybe we can find a better way to deal with that in the future. But again, before I'm going forward to have that, think about that structuring of the functions, I'm letting the arrangement of my functions emerge as we go. So I just want to do the throwing in line here in this big function before I refactor it around somewhere else in the future. So now we can say, if there's a last qualifier, so if there is a last qualifier, let's just do nested ifs for now, it'll be fine. So now I need to see if this is a valid qualifier. So before I figured out how to calculate that, it's like, is not a valid qualifier for attribute. If it's not a valid qualifier for the attribute, we're going to throw an error. Throw new error, and I forget the error message, so we'll just see as we go. So how can we detect if it's not a valid qualifier for the attributes? In fact, actually, I wasn't even planning this, but just having this kind of placeholder variable has already given me an idea for a function that we can create. So I'm going to go ahead and do that. But I'm going to invert it to say, is valid qualifier for attribute, and I'm going to say, how are we going to do this? Attribute. So this is interesting. I actually need to look up the attribute out of the list of the attributes now. What is that data structure? Yeah, okay, it's indexed. So the actually, I'll say attributes, attribute name, and then the qualifier is the last qualifier. That's getting long, so let's put that on multiple lines. Name qualifier is last qualifier. now that it's on multiple names, I think I just want to say attribute is attributes. So is this a valid qualifier for the attribute? So let's copy that and define this function. Our linter is telling us that it doesn't exist. So we're going to take in the qualifier and then the attribute configuration there. And then this we can probably do like this, just as a single return value. So we say attribute, if the attribute qualifiers includes qualifier. So let's see if that passes the test. Can I read property includes of undefined? So this might be, this is a different test erroring out. Yeah, no, that's still happening. So I've done something wrong here. So what is it? Let's get that there. Attributes, attribute name. Well, I need to put this in block form so I can get some helpful output. Log attribute. So let's log out that attribute and see what it is. Big and small. Okay, so check it out. The problem is that we did not have qualifiers set up for the attribute, the attribute size. So I could add that value in, or I could handle it here. So I think I want to handle it because I'd like to keep this configuration clean where we don't have to provide qualifiers. So let's say, actually let's just do qualifiers and set a default value of empty array equals attribute, and we might be able to kind of improve the performance of that in the future. Let's save this change. Something's still erroring out. Okay, so check it out. At least I think there's several errors happening. We'll have to look back into that, but at least in this case it's passing. We expected the function to throw an error including dark cannot be applied to big, but got an empty string instead. So let's kind of provide that error here, and we'll say error last qualifier cannot be applied to attribute name. And I think that will get it to us. Expected dark cannot be applied to big. Oh, no. We want the value. Maybe that gives us an idea for a different error name we could use in the future. Okay, so check it out. So we're getting some kind of errors here. Interesting. Very cannot be applied to big. Oh, this is a configuration problem. So we have these tests about very big, but we did not configure it that way. Now, I don't mind the fact that I put this null check in here. I actually like that, and so I want to keep that in there. So let's add these qualifiers in. Very, and you can even do slightly. Now everything is passing. So this is great. So now our app is now saying, hey, there's qualifiers that apply to colors, and there's qualifiers that apply to qualifiers that apply to sizes. This has already given me an idea for the next test we could do. And actually, let's maybe put it in here and get it to fail. So light dark red doesn't make any sense. And so I think I'm actually surprised I didn't think about this before. These things happen. So we've said throws an error upon conflicting attribute values. I think we also want throws an error upon conflicting adverbs. In fact, I think conflicting qualifiers for attribute red. So this is not going to work. It did not throw an error. But I think even this, even having conflicting ones, I think before that we even want the ability to handle multiple modifiers. Multiple qualifiers, I mean. Parses multiple qualifiers for an adjective. So what would be different ways that colors are modified? I think rich, dark red could be an option. Like it's dark, but it's rich or vibrant. Pale. Actually, I think pale makes more sense. Like light pale, because you could also no, pale implies light gray, dark pale. Well, maybe that's not best. Light pale, we'll say, or desaturated. This also fails. So we're going to want to get this working. So this has given me, I've kind of left some failing tests in here that are going to give me a sense of what to do next time. Maybe I'll commit the code without those included. Below fails. Now this gives me a good standpoint. I should be back next Friday. This is about all for our time for now. But next Friday, which I think is the 28th, I should be fine to stream. So let's plan on that. I'll see you back then. Let's keep on going with TDDing out this function. I hope this is enjoyable. I hope it's helpful to you to think about. And I think especially today we got to see some of the changes that we could make as we went. We didn't need to think through this data structure at the start. We were able to change it as we went. I didn't want to have to think about from our very first test where we just said dog, to think about the colors and the values and the qualifiers. I mean, who knows what other kinds of flexibility that natural language is going to require us to put in here. But for now, we're able to write it one test case at a time. And we even deferred getting into multiple modifiers until it made sense, until we had a good example to get us into it. So that's all we got. I hope you have a happy holidays if you're celebrating holidays the next week. So enjoy some time off if you got it. Otherwise, look forward to your holidays another time of year if you've got them coming up. I will catch you on Twitter. I'll catch you on Discord and various React and Vue and Ember.js Discords. Hit me up on Coding It Wrong on Twitter, or on Josh Justice, I think is my name on most of the Discords. I would love to hear from you and how your testing journey is going. So thanks a lot, and we'll catch you next time. See ya.